so the fundamental theorem of algebra we talked about yesterday. That's when the degree is equal to the number of zeros that you have. So there's a corollary to that that helps us write out polynomials of least degree when you are given roots. So way back in chapter 2, I actually gave you some roots, and you had to write the polynomial. Okay, and we did that using FOIL. We're going to do really the same process. It's just some of our roots are going to be more complex. So the first thing we want to remember is the factor form. And you guys have writing polynomial functions when you are given zeros. It says, recall, how do you write 0 as a, the 0 of 1 as a factor? And then I said, what about -1 and 0? So the first thing we're going to talk about is factor form. Okay, so you have zeros and you have factors. Okay, factor form is x minus c, okay, where c is the 0. Okay, where c is really the 0 or the root, because those are interchangeable. Alright, so if you have the 0 is 1, remember that's like x equals 1. Do you guys know how you would write that as a factor? So if it's x minus c, what would it be? X minus 1. So the factor form is x minus 1. And really we are going to write it as a factor like this today. Okay, and that makes sense because if you were to solve it from factor form, you would set it equal to 0 and solve, right? So if you had x minus 1 is equal to 0, you would add 1 to both sides, and that would give you x equals 1. So factor form is really just the reverse of solving. Okay, and that's why we can use the x minus c. All right, let's do, if it says, so the 0 of 1, and then it says, what about -1? Okay, so if x was -1, what would the factor form be? Yeah. Factor form would be x plus 1. And again, we talk about how it's x minus c. So this is just like x minus -1. What happens when you have minus a negative? Yeah, it becomes the positive. That's where the x plus 1 comes from. Okay, the last one says, what about 0? So if your x is 0, this one you actually can simplify. So if I'm using my factor form, x minus 0 is just what? X. So your factor form, if your 0 is 0, would just be x. Okay, and these were the type of zeros that we would have when we did this earlier. Okay, we'd have integers. But we are going to get into complex roots now. So remember, the complex conjugate of a plus bi is what? A minus bi. So that's something that we talked about before. Okay, but it's also true that if a plus bi is a root, then a minus bi is also a root. Okay, so that means if you have a complex value, the complex value and its conjugate, they both have to be zeros. Okay, so if a plus bi is a root, a minus bi is a root. Okay? And then it says, why do you think this is true? And I told you to think about when you encounter complex numbers, which remember is just another way to say imaginary. Imaginary and complex are the same. Okay, so we talked about this yesterday. Complex roots, except we didn't talk about this with complex. We talked about this with the irrational roots. Okay, complex roots work very similarly. So complex roots come in pairs because they are generated from what? When does the I come? When do we have to include that? Yep, a negative under the square root. So they are generated from a negative under the square root. Well, what did we talk about yesterday about the square root? When you take the square root, what happens? When you take the square root, what happens? What comes along with that? Yeah, the plus or minus. Okay, so when you take the square root, it will result in a positive and negative solution. Okay, so this is true because the complex roots are going to come in pairs. They're generated from a negative under the square root, and we know when we take that square root, it results in the positive and negative solution. It's going to have that plus or minus. Okay, so what we're going to do today is we are going to practice writing those polynomials, and we're going to use this complex conjugate corollary, and we're also going to use the irrational number theorem that we talked about yesterday. So this is to write the simplest polynomial function with the given zeros. So I'm going to give you those zeros in a minute. Just know when it says the simplest polynomial function, what it means is you are going to write the polynomial function with the least degree possible. Okay, so the simplest polynomial function is going to be the polynomial that has the least degree. Okay, and then you will be given zeros. Okay, your zeros in this case are all going to be rational numbers. So we're going to start with that. -1, 2/3, and 4. Okay, I wrote out these steps so you could use them for any type of zeros that you have. So some of these steps are not going to be in the first one. And number 1, where you're listing all the zeros, the main thing you have to look out for are roots that are complex or irrational, but we don't have any of those. So for number 1, when you're listing all of the zeros, it really is just going to be the same as the ones that are given, -1, 2/3, and 4. And so what we take from this is there are 3 zeros, which means the degree of the polynomial that we're going to generate has to be of degree 3. Okay, and then you're going to rewrite all of your zeros in factor form, but there's a stipulation. Okay, the stipulation is there has to be integer coefficients. Remember we talked about integers yesterday? Do you guys remember what the integers are? What are integers?
Real numbers that can be positive or negative.
Yeah, they're positive and negative, and they have to be whole numbers. So that means they can't be what? Can't be fractions, which kind of makes
going to make us a little sad in a minute, unfortunately. But I'm going to show you how to fix it. Okay, so when you're rewriting them in factored form, -1 and 4, okay, that's going to be fine. Okay, but if you were to write these out, okay, -1, what would that be in factored form? Okay, x plus 1. So if it's -1, it's going to be x plus 1. Now the problem here is, because it says integer coefficients, okay, with this one, I would want to write it out as x minus 2/3, but why can't I? Yeah, this is not an integer. Does anybody know how we can transform it so it's not an integer anymore? Yeah. Yes. How do you know? How did you know? Yeah. Yep. So if you look at the denominator of your fraction, just multiply this by the denominator. Right? Let's just multiply 3 times x minus 2/3. So 3 times x will be 3x. And then what happens when you multiply a fraction by the denominator? What's 3 times -2/3? What happens? The 3 and the 3 are going to cancel, right? 3 divided by 3 is 1, so you're just going to be left with -2. And then that is going to be your factor. Okay, so that's going to be your factor with the integers. Okay, so I'm going to put that here, the 3x minus 2. And like Lizzie was saying, if you were to set this equal to 0 and solve, you would add 2, divide by 3, and you would get the 2/3. Okay? So this is going to be your factor form. All right, and then the last one is 4. So what would factor form be of 4? Yeah, x minus 4. Okay, and then this is very similar to what we did earlier in chapter 3. We just have to FOIL these together piece by piece. And you can decide, do you want to FOIL the first 2 together? Do you want to FOIL the last 2? Do you guys know what I'm going to do first? You guys remember what I like to do? I like to do the last 2, because when I distribute, I like it in front. It really does not matter. Okay, but we're going to FOIL. Okay, so 3x times x is 3x squared. Then I have minus 2x. -4 times 3 is -12x. -2 times -4 is +8. And I know some of you are very proficient with FOIL, and you can combine that right away. That is perfectly fine. I recommend it if that's something you're comfortable with. Okay, and then from here, we're just going to distribute. Remember we did these problems in chapter 3 earlier? So you just distribute x to everything. So if I'm distributing x to everything, the only thing that's happening is the exponents are going up by 1. So 3x squared minus 14x squared plus 8x. And then I'm distributing 1 to everything. Well, if I multiply everything by 1, I just get the same thing, right? So 3x squared minus 14x plus 8. Okay, and then I'm just going to add straight down. So this would be 3x cubed minus 11x squared minus 6x plus 8. Okay, and then when you write the polynomial in standard form, I'm fine with you writing either p of x equals, or you can write f of x equals. I don't care if you write it in function notation or the polynomial. Okay, and then if it's in standard form, that just means you have decreasing exponent order. All right, now, sometimes when you are looking at your final answers, okay, they can be written in different forms. Okay, so like this is perfectly fine, but sometimes they might say, oh, you have to write a polynomial where the leading coefficient is 1. Okay, if the leading coefficient has to equal 1, then what could I do to this polynomial so that this was a 1 instead of a 3? What would I do?
Divide by 3.
Yeah. So I'm going to divide everything by 3. Okay, so an alternative answer could be p of x equals, if I divide that by 3, I get x cubed. What's negative 11 divided by 3? Just negative 11 thirds. Negative 6 divided by 3 is negative 2x. Okay, 8 divided by 3, we're just going to leave it as 8 thirds. Okay, so if you notice that you're checking this and there's an alternate form, okay, I want you to be able to recognize it. And that's a good thing to help you on tests like the PSAT or SAT where it might be written in a different form. Okay, now on the back we're going to start to add in different types of roots. So if you have roots that are imaginary, we're going to do a process of regrouping, and of course I'll walk you through that. It's also going to happen if you have irrational roots, okay, but we are going to do FOIL in the distributive property. When you do get complex roots, okay, you're going to multiply them together first, and then when you have complex roots and you're multiplying them by each other, do you guys remember what sometimes happens? You get I squared. And what do you plug in for I squared? Yes. Okay, so we're going to have to plug in negative 1 for I squared where necessary. Okay, and this is going to happen in parts B and C on the back. Okay? Okay, so the first thing I want you to do when you're looking at part B, okay, is I want you to look at the zeros, and if there are any conjugates that need to be added to your list of zeros, we're going to add them now.